7.6 is solving exponential and logarithmic equations. So starting off, let's look at the property of equality for exponential equations. If I have b to the x equals b to the y, then x equals y. And that works in both directions. That's my if and only if. So example, 3 to the x equals 3 to the fifth. That means x equals 5. On the same token, if x equals 5, then I can say 3 to the x equals 3 to the fifth. So let's use that now in example 1. I have 100 to the x equals 1 over 10 to the x minus 3. So we want both sides to have the same base. Even though there's a 10 in the denominator here, I'm still going to use a base of 10. So I'm going to rewrite 100. Well, just over here to the side, that's in highlighter. Over here to the side, I'm going to make a note that 100 is equal to 10 squared. So I can rewrite this side as 10 squared. But don't forget there's an x right there, so I'm going to put an x still in that exponent. Over here, remember that 1 over 10 is equal to 10 to the negative 1. So I can rewrite the right side as 10 to the negative 1, and then I still have this x minus 3 in the exponent, so I'm multiplying that by x minus 3. Now that my bases are the exact same, I can cancel them out and just use the exponents. 2x equals negative 1 times x minus 3. Okay, so now I just need to distribute that negative 1. I have 2x equals, well, negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. Now let's just solve. So I'm going to add x to both sides of my equation. 2x plus x is going to give me 3x, and that's equal to 3. And then I'm going to divide both sides by 3. And now x is equal to 1. So then on example 1b, 2 to the x equals 7. There's no way that I can rewrite 7 using a base of 2. There's also no way I can rewrite 2 using a base of 7. But my x is in my exponent, and so I've got to figure out a way somehow to rewrite this and get that x out of the exponent. Well, we know that if I have log base x of x, if my base and my number here I'm taking the log of are the same, then they cancel. So if I'm trying to cancel out this 2 right here, I can write down log base 2 on both sides. So log base 2 of 2 to the x equals log base 2 of 7. So all I've done here is multiplied both sides by log base 2, and that's so that I can cancel out that 2 here. So now that the base and the 2 are the same, they can cancel, and that tells me that x is equal to log base 2 of 7. And from here, you're just putting that in your calculator. So when you put that in your calculator, you are going to get, one second, you are going to get 2.807. Because we're multiplying, we are rounding to 3 decimal places there. I can't talk today. Alright, example 2. Example 2 is kind of long. You are cooking a leche and an Ethiopian stew. When you take it off a stove, its temperature is 212 degrees Fahrenheit. The room temperature is 70 degrees Fahrenheit. And the cooling rate for the stew is R equals 0.046. How long will it take to cool the stew to a serving temperature of 100 degrees Fahrenheit? We need some type of formula. So the formula that we are going to use is dealing with temperatures and cooling rates and everything like that, and I'm going to give you that formula. It is T equals, parentheses, T sub 0 minus t sub r times e to the negative rt plus t sub r. Okay, so if I'm looking at the numbers that I'm given here, I'm trying to get to a serving temperature of 100. Well, this T at the very beginning is my serving temperature. So we can make a little note right there. That is, in this specific problem, serving temp. So then I'm going to plug in 100 for that. And this T, whoops, oh, I just messed that all up. There we go. This T sub 0 right here is going to come from the original. So when it came off the stove, the 212, we're just going to call that original temp. And that is our 212 minus the T sub R is going to be room temp. So R comes from room temp. So this is our room temperature. And we can plug that in as 70. E to the negative. Well, the R up here, the little r is our rate. So this little r right here is your rate, and we're given that in the problem here. So that is 0.046. The t right here, I don't know. It says how long will it take? I don't know. So that's what we're trying to find. This t right here is time. And that's something I'm going to leave right there. Plus T sub R, which again is the room temperature. So that's going to be 70 again. Okay, so now let's just solve this as a normal algebraic equation. And so I'm going to start off because I need to get T by itself, which means I need to start off getting E by itself. So let's subtract 70 from both sides of the equation. 100 minus 70 is going to give me 30 equals, let's work inside our parentheses here while we're here. 212 minus 70 is going to give us 142, and that's times e to the negative 0.046t. So now that I've moved that 70, that's all that's left right there. Let's go ahead and keep solving. So we're going to divide both sides by 142. 30 divided by 142 is 0.2113, and that is equal to e to the negative 0.046t. Okay, now then, if you think back to our previous couple of lessons, think back to what will cancel an e. So if we multiply both sides by ln, ln and e cancel each other out. So now we have ln of, which is natural log, of 0.2113 equals natural log of e raised to the negative 0.046t. So if I'm looking at ln and e, they cancel each other out, and that drops that exponent down. So now I have natural log of 0.2113 equals negative 0.046t. To solve this, just divide by negative 0.046 on both sides of your equation. Now, when you put this in your calculator on the left side, you're going to make sure that you put it in parentheses. And so if I am dividing, make sure that that 0.046 is not in the log right there. So go ahead and put parentheses around all of this right here just to make sure you're putting everything in the calculator correctly. Now when you get that out of the calculator, you are going to get 33.8 is equal to t. So that tells us it will take about 34 minutes. All right, let's look here. So the property of equality for log equations. A while ago we looked at exponential, now let's look at log. So if I have log base b of x and log base b of y, then x equals y. So as long as the log and the base are the same, then I can say that x equals 7 there. So also if x equals 7, then I can say that log base 2 of x is equal to log base 2 of 7. I could have also said on this one log base, I don't know, let's say 6 of x is equal to log base 6 of 7. As long as the bases on those logs are the same, it's okay. It doesn't matter what they are. So in the same note, let's look at natural log there as well. I can also say that the natural log of x equals the natural log of y, so then x equals y. So just like I put natural log here, I can put, or just like I put regular log of 6, I can put natural log too. They're kind of interchangeable, you just have to be really careful. So let's look at example 3. Natural log of 4x minus 7 equals natural log of x plus 5. That's already set up to cancel. They both have a natural log. I can cancel it out, and then I have 4x minus 7 equals x plus 5. Now you just have an equation to solve. So we're going to take and subtract x from both sides. And I'm going to go back and do this all in the same step here. Now I'm going to go and add 7 to both sides. So the 7 comes from here, and I want to cancel that. The x came from the right side, and I'm canceling it. So 4x minus x is 3x equals 5 plus 7 is 12. Now just divide both sides by 3, and x equals 4. If you don't want to do all of this in one step, that's perfectly fine. You don't have to. You can do 2 steps. Not a problem. All right, B. Log base 2 of 5x minus 17 equals 3. Well, there's no log on the right side. But remember that if I have a base and a number, they can cancel each other out. So this one's kind of backwards. I have log base 2. Well, we know that our regular 2 will cancel that. So let's put a base of 2 on both sides, which means that everything else goes up to the exponent. So 2 raised to the log base 2 of 5x minus 17 equals 2 raised to the third power. Now this base and this log base 2 cancel. So I have remaining 5x minus 17 equals 2 to the third power. Well, 2 to the third power we can work out. That's just 8. Now let's solve. So we're going to add 17 to both sides. And we have 5x equals 25. Now all you've got to do is divide both sides by 5. And x equals 5. Okay. Example 4. Example 4 is going to be a little bit long. We have 6 examples total. So bear with me on example 4. It's a little long. Solve log 2x plus log of x minus 5 equals 2. This 2 right here is not a base. It's just log 2x. So if I'm trying to solve that, let's condense this left part. This left side of the equation, let's go ahead and condense it. So since I have a plus right there, I can write both of these in the same log, and I can put 2x times, instead of plus, x minus 5. And that's equal to 2. So that's the condensing from 7.5. Now go ahead and distribute that so that you have log of, well, 2x times x is 2x squared. 2x times minus 5 is minus 10x equals 2. So now I need to try and cancel out that log so that I can solve this equation. Well, anytime, don't forget, anytime there is no base, it is base 10. So how can I cancel a base 10? Well, I can make each side have a base of 10 and raise it to the power. So we have 10 to the power of log base 10 of 2x squared minus 10x equals 10 squared. So now log base 10 and 10 cancel, and I have what's left of that exponent as just a regular 2x squared minus 10x equals 10 squared. Well, we know that 10 squared is 100, so let's rewrite that. 2x squared minus 10x equals 100. Now we just have a quadratic. We've solved quadratics 100 times. Let's subtract 100 from both sides, so everything's on the left. So now I have 2x squared minus 10x minus 100 equals 0. Well, if we're going to try and solve this, first, the easiest thing to do is going to be divide every single solitary piece by 2 because of that 2 out front, and that's going to help us factor better. So we have x squared minus 5x minus 50 equals 0. Okay, so if I'm going to factor this now, let's use P and S. Well, I need a product of negative 50 and a sum of negative 5. So what two numbers are going to give me a product of negative 50? Well, the first numbers that come to my mind are 10 and 5. But I need negative, so I want negative 10, negative 5. Sorry, negative 10, positive 5. Well, then when I add over here for the sum, negative 10 plus 5, it works. That gives me negative 5. So those are my two factors. So I rewrite this now as x minus 10 times x plus 5, and that's equal to 0. From here, don't forget, you separate. X minus 10 equals 0, and x plus 5 equals 0. Add 10 to both sides. I'm the one on the left, so x equals 10. And then I'm going to subtract 5 from both sides, and x equals negative 5. Now then, the big thing here is that we need to check our answer. So we're just going to plug it into the calculator and check our answer. Let's go back to the original equation that said log 2x plus log x minus 5 equals 2. So let's start with 10. Let's plug that in. Log of 2 times 10 plus log of 10. That was supposed to be in blue. Here we go. 10 minus 5 equals 2. So just to make this easy for you, take this entire left side and put it in your calculator exactly as is. If it asks for a base, don't forget you can put base 10, or really you can just leave it blank. So when we do that, when we put that entire left side in our calculator, we get 2, and the right side is 2. So this one checks out. Now, all we have to do is check the second one. And the second one, we have log of 2 times, let's use negative 5 now, plus log of negative 5 minus 5. And let's see if that equals 2. So right here, we didn't know for sure if it was going to. So we don't know for sure here if it's going to. When I put this left side in my calculator, I get an error. And it's because I can't put a negative and I can't take the log of a negative number. So the calculator gives me an error. Well, error does not equal 2. So that means negative 5 does not work. 10 is the only answer that works there. Okay. These last two should be pretty quick. I'm sorry, this video is so long. It's probably the longest one yet. I'm trying to make them shorter. Solve 3 to the x less than 20. Well, if I have 3 to the x less than 20, I need to get that x out, so I'm going to put both sides to log base 3. Remember, the base of 3 and the 3 can cancel each other out. So log base 3 of 3x less than log base 3 of 20. Now these cancel. So I have x is less than log base 3 of 20. Then just put that right side in your calculator. So now I have x is less than 2.727. And there we go. Example 6, this is our last one. I have log of x is less than or equal to 2. Don't forget, if there is no base, it is base 10. So I can put a new base of 10 on both sides to cancel this out. So 10 raised to the log base 10 of x is less than or equal to 10 to the second power. So if I already have a log here and I have to put a new base, the log becomes the exponent. So those cancel, and I get x is less than 10 squared. So 10 squared is 100, x is less than, or equal to 100. Only thing is, here's the catch. You are not finished with this problem, because just like we said in example 4, you cannot take the log of a negative number. So right here, this is taking the log of x. So I can't just say that x is less than or equal to 100. I have to give a restriction there, and it has to always be positive. So I have to put 0 is less than or equal to x, which is less than or equal to 100. That way, it keeps my x positive. So if you need to, make a note out here to the side. You cannot take the log of a negative number. So just a key thing to remember there. Cannot take the log of a negative number. Don't forget. Okay? And that's it. We are finally done.